Section 7.5, we're still going to do proportions, okay? This whole thing is about setting things proportional to each other. There's a lot of stuff to remember on this, okay? A lot of different things going on. So taking notes is of utmost importance, I believe, to this. I mean, when you take notes, you got it all in front of you. All you got to do is flip a few pages, okay? You can't rely on YouTube videos. I mean, that's helpful, okay? It's a good tool. But it's not the greatest thing in the world because you have to have a computer. Then you got to log on, and then you got to find the right lesson. Then you got to scroll through and find the part that that you had a question about. But if you take good notes, you can always just flip to your notes and see what we're doing. And if I told myself I wasn't going to do this, so let's just teach the lesson. All right. So because it doesn't make any difference anyway, apparently. So if you want to take notes, feel free. And if you don't, and you want to sit there and do other classwork like I see some of you guys doing, then that's up to you too. So if you'd like to fail this test, then you take full responsibility, and then enough said. All right? So here we go. What we're going to do here is we got a triangle, and this is called parts of similar triangles. All right? So you're going to have similar triangles, and we're going to talk about the parts of the similar triangles. All right. So the first type of triangle, what we're going to do here is we are going to draw an altitude. Actually, I made this way too big because I need to put two of them here. I'll make one bigger and one smaller. Come on. Scooch over. There we go. I'm going to copy and paste it. Make this a little bit smaller. All right. So you can see that they are proportional. All right. They are similar. I should say they're similar triangles. Okay. I just copied and pasted. Just made that one a little bit smaller. What we're going to do is, the first thing we're going to do is we're going to draw the altitude. We've used these words before, so we're going to use them again. We're going to draw the altitude. Did I spell that right? Altitude, yep. Of the triangle, and then we're going to see how it splits these triangles up. So watch this. I'm going to take this. What's the altitude? It goes from a vertex perpendicular to the opposite side. So I'm going to take this perpendicular to here. I'm going to come over here and do the same exact thing. Now, are those altitudes equal to each other in length? No, absolutely not. This one is much longer than this one over here. Let's make that look a little bit more like a right angle. Here we go. Okay, so this one is much bigger than this one right here. So they're not the same. They're not congruent triangles, but they do split some things up into proportional parts. Let me just show you what it says. It says if two triangles are similar. So I've already established that those two triangles were similar to begin with. It says the lengths of the corresponding altitudes are proportional to the lengths of the corresponding sides. So it'd be a lot easier if I tell you what. Let's do this a little different than they do. Let's see. AD to FJ is equal to AB to FG. Yeah, let's do it like this. Watch. Let's call this A, B, and C. All right? And we'll call this D, E, and F. D, E, and F. We'll do it like this. I think this might be a little bit easier for you to see than using all these letters, making all the points of the triangle. I think it might be a little simpler. Here's what it says. It says the lengths of the corresponding altitudes are proportional. So what we're going to do is we're going to set up a ratio between the two altitudes. So what's the altitude in this first triangle right here? It's C, isn't it? Let's do a different color. So I'm going to compare this altitude to this altitude. So what's the altitude over here? It's F. See what I'm doing? I'm making a ratio between the two altitudes. All right? I'm going C to F. Now, what does it say? It says the corresponding altitudes are proportional to the lengths of the corresponding sides of this triangle. Okay? So, now watch. If I compared the big altitude to the little altitude, let's compare A to something. What do you think I could compare A to? A to D. Everybody see that? All right, so if I go C to F, I could go A to D. What's another side I could do? I could go B to E, couldn't I? All right? And if you wanted to, let's call this right here. Yeah, I think we can still do this. Okay, let's call this whole thing EF, what, G? Call it G and H. Is that all right? All right. So if you wanted to, you could also say what? G and H. Everybody see that? Now, you're not going to use like all four of these at the same time, but you can compare them. So if they give you some numbers, you can just put them in. You're only going to pick two of these, okay? And they'll give you three of the four things that you need to know. Plug it in, do some cross multiply, just like we've been doing lately, and then it's no big deal. It's just learning new proportions. That's all we're doing right here. Does that make any sense? All right, so if I compare this altitude to this altitude, it's going to equal the corresponding sides. Okay, compare the corresponding sides. So A and D go together, so I put A over D. B and E go together, so I put B over E. All right, so this is all about the altitudes. What is an altitude? It goes from a vertex perpendicular to the opposite side. Okay, we've dealt with altitudes before. All right, so hopefully you have that written down. Let's do another one. Let's scooch this over here. And let's copy and paste it, make another smaller one about like that. Now we're going to do another one, but we're not going to do altitude this time. Let's see what the next one in line is. It's the angle bisector. Okay, so let's write that down. So now what we're going to do, let's make that a little bit better. Okay, now what we're going to do is we're going to do the angle bisectors. And you can pick any of these angles. It doesn't make any difference. Let's just go to this top one right here. Is that all right? And I'll tell you, I should have done this in the other one. Let's make the angle bisector different color. So watch. If I go here, what am I doing? Am I going straight down? No, that would be an altitude. Okay. Do I go to the midpoint? No, that would be a thing called the median. Remember that? What is the angle bisector? It takes this angle and it does what? Splits it in half. That's right. So I'm not necessarily going to the midpoint of the opposite side. What am I doing? I'm taking this angle right here, and I'm trying to split it in half. So we'll just kind of look at it and just decide where it's supposed to go. Does that look like it split that angle up top? Yeah, that looks pretty close, doesn't it? All right. So that split that angle in half. Let's just write it in there so that we know. So this angle and this angle are equal. So that's an angle bisector. That's not new. We've talked about angle bisectors before, so I'm not going to get into that real deep. Now what we're going to do is come over here and do the same thing with the angle bisector. So we're going to take this angle, we're going to bisect that angle as well. And that looks about right there. It's pretty close. And so this and this are equal to each other. So there we go. We've got angle bisectors. Now what do you think might be true? Very, very close to what we did with the altitudes. Let's do the A, B, and C again. I went A, B, and C. Is that how I did it? And then D, E, and F, like that. And we'll just use these. We won't do this bottom one. We'll just do these right here. So what do you think I'm going to compare? I'm going to compare the angle bisectors to each other. So let's compare what? C to F. And what do you think that's going to equal? A to what? A to D. It's the same thing, isn't it? And then what else? B to E. Yeah, pretty easy, isn't it? Has to be an angle bisector, though, for this to be true. So we did that with an altitude, and it looks, I mean, look at this comparison. It looks exactly the same, doesn't it? All right, but you're doing it with a different information. Okay, you're not doing it with a what's the word? Altitude. You're doing it with an angle bisector this time. All right, the next thing we're going to do looks incredibly like what we just got finished doing. All right, so it kind of looks like it's the same thing, and they do clump them together. If you look at page 495, there are three different theorems: 7-9 or 7-8, 7-9, 7-10, but there is a slight difference between these, okay? Because they're not all altitudes, they're not all angle bisectors, and let's do this in this pink color. Now, what are we going to do now? I actually mentioned this word a few minutes ago. Not the angle bisector, not the altitude. What was the word that I mentioned earlier? The median. What is the median? The median does what? It goes from a midpoint to the, it goes from a vertex to the what? To the midpoint. That's right. So I'm going to put a little dot right there. Let's find the midpoint of this one. Be right there. So put a dot right there. All right. So now what I'm doing is I'm going from this vertex to this midpoint. Does that mean that bisected this angle up here? No, not necessarily. Okay. Now, if it was an isosceles triangle, it would, but it's not. So, what did I do? I hit the midpoint right here. And how do I know it's the midpoint? Because those two segments are equal to each other. And then guess what I'm going to do over here? I'm going to hit the midpoint right here. Okay. And so that must mean that these two are equal to each other. What did I just do right here? I found the what? The median. The median, remember that little story I told about the median in the middle of the road, that grassy area in the middle of the road? Okay, that's the median. All right, I told a story about this guy I knew. He called it the medial strip. Do you remember that story? Okay. Well, anyway, I did. So it's the median. Median means the middle. It's in the middle of the road. It's that grassy area in the middle of the road, or that concrete area right in the middle of the road. Okay, that's the median. So I go from a vertex to the middle, right, to the midpoint of the opposite side. Now, what do you think is true about this? Let's label it again. And just to be consistent, I'll label it the same exact thing. A, B, C, D, E, F. I think I labeled it like that, didn't I? Okay, so let's first of all, let's compare the medians to each other. So which ones are the medians? C and F. So I compare them to each other. What should that equal then? A to D looks exactly the same as what we did before, doesn't it? And B to E. All right. So those are your special parts of your triangle. We good with that? All right. Let's do an example. So now we have that down. Now I made these really simple. Look, I made these triangles all sit in this same exact way, go from here straight down, from here straight down. But guess what could be true about some of this?
Please excuse the interruption.
You might have it like this, right?
We have a formal affairs will be in the upper school lobby during first and second lunches today for tuxedo rental for the prom. They will be here today only, so make sure you stop and see them during first or second lunch for tuxedo rental. Thank you.
All right. I thought they already announced that this morning. Yes. Get a worksheet. Okay. It's page 91, I think. Okay, watch this. Let's do a quick little example before we go. She's not renting a tuxedo. She's helping Brianna because she has to get out of class early. So she's... Okay, I think they flipped this. Reflects. Alright, let's see this. Guys, hush. Let's pay attention up here, please. Guys. Alright, let's do this. Daniel, end it. Do you not understand? Just keep going. Don't know when to stop. Alright, and look what we do. They do this. They say this. Watch what they do here. They say that that's equal to that, so that's an angle bisector, isn't it? And then they also do an angle bisector over here. So I'm looking at this angle. I'm trying to bisect that angle. Probably around in there somewhere. Alright, it's close enough for us. And they tell you that this is 15. They tell you this is x. They tell you this is 8. And they tell you this is 12. Alright, so what we have to do is, we've got angle bisectors, right? And remember, they're in proportion to the other sides of the triangle. So let's compare the angle bisectors first. So what are they? Yeah, let's compare the left one to the right one. So it's x to 8. Alright? Now, what do you think about this one? What are we going to do here? Yeah, it'd be 15 to what? To 12, right? Because that's the corresponding side over there. So 15 to 12. And that's all the geometry right there. Okay, that's what we learned today. That's exactly what we learned. We compared the angle bisectors. These are the two sides that they gave us. I compared the big one to the smaller one. And now you can solve for x. So we solve for x. So it's 12x equals 15 times 8. I don't know. What's 15 times 8? 15 times 8. That's 120. That's easy then. Okay, watch. Divided by 12. So that's 120. What's 120 divided by 12 in your head? It's 10, isn't it? And so x is 10. And that's all there is to it. Let me give you a worksheet before you go. And that's your homework for tonight. Oh, I am still recording. Let's...
It's fun. It's fun.